Hello, calculus class. I tried in periods 3 and 4, live in class on Thursday, to use some available technology out there to help visualize these things better. I've been teaching this topic, finding the volume of solids of revolution, for like 15 years. I basically just never use technology. I just draw it and use everyone's imagination. But okay, that's harder to do, maybe remotely. So if we're all sitting in front of our computers anyway all day long, why don't we try to make use of this? There are a million resources out there because like everyone in America takes calculus and everyone learns this topic, and some people find it very hard. Anyway, despite that, I kind of hate every single thing I can find. So after playing around with like 10 different ones, I guess this one is best. I tried to use this one live in class, so I'll put a link to this so you can play around with this. This might help you. It's not super user friendly, but it kind of is. So if you look at this, we have a space for f. This should be the function of the top, g the function of the bottom, a and b the lower and upper limits of integration respectively, and then we can change the number of subintervals as well. Okay, so let's try to do how should I do this? Let's try to do this problem. Let's see if this is showing up. Oh boy. Yeah. So this is a picture I took. This is a screenshot from the Jamboard from class. I believe this is period 4, and this is this problem we did with washers, where we took the line y equals x and y equals x squared, where you rotated about the x-axis. So, okay, to me this is relatively clear what's going on, but if it helps you, why not use technology? Woo, haircut needed. Okay, so this is the one I'm going to try to do. All right, how? Going back to this website, well, the function on top is x. The function on the bottom is x squared. And here we're starting not at -6, but at 0, and we're ending here at 1. All right, here's where I start to find this a little bit annoying. I should also probably make this bigger. That's going to look a lot better. Okay, there's no like obvious way to zoom in, so you sort of have to just sort of manually zoom in. And some of this stuff is a little bit annoying, but maybe I'm being kind of a brat, and maybe it's actually just totally fine. N equals 3 seems like not enough, so maybe I want to do like n equals, maybe I want to do like n equals 7. So here we see the region between 0 and 1, shaded, I guess, between x equals 0 and x equals 1. And now we're going to rotate this about the x-axis. So let's go. So if we perform that rotation by sliding this, you can kind of see, and I say kind of, the whole thing sort of moving around and the shape being formed. Now, here is where you need to kind of rotate this a little bit. It's not totally obvious how to do this, but there should be some way to get like a new angle. Yeah, there we go. This is the this is what I mean when I say it's not super user friendly, because it's not easy with one mouse to sort of be able to rotate in 3 dimensions, but you get the hang of it a little bit. Maybe you guys don't find it that hard at all. If we change this to like maybe n equals 6, the fewer subintervals you have, the easier it is for the, that's looking pretty good now. The easier it is for the computer to handle this. Okay, so I finally kind of got the gist of this a little bit. By doing this rotation, you can sort of see the object, and now by continuing the slide, are you guys kind of feeling this? All right, this is definitely worth it. And I don't know what filling means exactly. I guess that's whether it's like, whether you can sort of see it or not. Interesting. So all right, so anyway, there is the shape. You get some kind of perspective there and some other kind of perspective here. And when you get an angle that you like, you can also increase the number of subintervals, and then it's going to look more like the solid actually looks. Then it becomes also kind of impossible to rotate, which is what I was complaining about earlier. So if you want to be able to flexibly do this rotation, then you need to keep it down around about 6 or 7. So this could be very helpful for you to visualize things. So hope this video helped. And I'll put a link to this website so you can play around with this, and you can type some of your own functions in. This will do, I guess this specifically washers. And the other thing is, it seems to only allow you to rotate about the x-axis. Therefore, this particular file at least won't do that last problem that we did in class where we rotated about the line y equals 2. Okay, goodbye.